Hello and welcome to this edition of Tech Talk. This is where we bring technical experts from Cisco
to share their insights on specific topics
selectively chosen based on most common conversation themes
on our technology area in community. Our topic for discussion will be
troubleshooting high CPU due to multicast,
understanding Cisco Unified Communications Security.
And I've seen this question coming up every now and then.
Very good explanation.
I hope it helps the audience.
Hi folks, and welcome to this brand new edition of Tech Talk here on the Cisco Support Community. Our topic for discussion today is Virtual Port Channel, also known as vPC, that ensures high network availability in today's data center operations. To talk more on this, today we have three experts. In the Bangalore studio, we have Vinay Kumar, a customer support engineer from Cisco High Touch Technical Support Team. He holds a CCI routing and switching certification and also an iOS XR specialist. Welcome, Vinay.
Thanks, Satish. Glad to be here.
Great. We have two experts joining us today from Gurgaon office via Cisco Telepresence and are from Cisco's Advanced Services team. Vivek Ruhil, a network consulting engineer with expertise in design and implementation of service provider networks. He has over 10 years of experience and holds CCI service provider certification. Welcome, Vivek.
Thank you, Satish.
Great. Another expert joining us from the Gurgaon office is Pradeep Malik, who is a network consulting engineer and expertise in designing IPv6 network. He has over 9 years of experience and also a double CCI in routing and switching and service provider. Welcome, Pradeep.
My pleasure.
Great. So in today's networking world, all service providers want to provide their customers a network with minimum downtime and maximum bandwidth. Isn't it true?
Yes, Satish, you're very right there. In today's data centers, there's constant worry about high availability and resiliency to ensure that customers can get to their data while maintaining a service level agreement which is very close to 100%. To achieve this, we as network administrators must ensure that we look at every possible way that the network or the gear that makes up the network could fail without impacting data transmissions. This is where virtual port channel comes in. vPC takes high availability to a whole new level in the data center. The whole concept of vPC is to club two physical switches together so that they form a single logical switch and appear to the connected device as just one switch. Now, before we talk about vPC, there are two things that I would like to talk about first. One is the traditional port channel, wherein you would bundle two or more links together to provide higher bandwidth. But at the same time, they're both connected to the same switch. And the second thing that I want to talk about is traditional layer 2 networks running spanning tree protocol. Now, as we all know how spanning tree works, one uplink will be in the forwarding state and the other uplink will always be in the blocking state, thereby not providing us all the available bandwidth for use. This is exactly what I love about virtual port channels or vPC. They help us bundle two switches together, like I just said, and provide us a port channel with both the uplinks to be used while ensuring that we do not get any STP block ports. Now, let's go more deep into the vPC concept. On this screen, you could see there are two layer 2 networks, one running the spanning tree protocol, which is most widely deployed and the feared protocol today in the world. And the other one is virtual port channel, which is a revolutionary technology by Cisco to ensure that we give you very high availability in the data center. Let's look at the STP domain first. You could see there is switch 1 and switch 2. They're both connected to switch 3 down below. Now assume that switch 1 is the root for the spanning tree protocol domain here. Naturally, like the protocol works, the link between switch 3 and switch 1 would go into the forwarding state, and the link between switch 3 and switch 2 will remain in the blocking state. Now let's think, what would happen if the spanning tree protocol fails or there's a protocol failure? The link that is between switch 2 and switch 3 will go into the unblocking state, and what we have for ourselves is an STP loop. We've all been there and we know how tough it is to troubleshoot an STP loop. I have in fact seen cases where I could not even log into the devices while they were already accessible. Now, and there are various scenarios where you could face a huge amount of downtime because of just the STP loop. Now, on the other hand, we have a VPC domain. You could see clearly on the screen that virtual port channel provides us the capability to bundle two links together which are actually connected to two different switches. In our case, switch 4 and switch 5. So switch 6 is connected to switch 4 and switch 5. As can be seen, there are no blocked ports on the screen in the right hand side, and we have all the available bandwidth available for our use. Now, VPC would provide you simpler network designs, loop-free topologies, and would ensure high availability and would give you very close to 100% SLAs.
You just mentioned about the loop-free technology that VPC provides. Can you elaborate a bit more on that?
Okay, let me take this question, Satish. So as Vivek mentioned, we have a VPC domain here where we have a switch 6 which is connecting to two other switches, switch 4 and switch 5 via two different physical links, and it forms a port channel. We have bundled them together and forms a port channel, virtual port channel. Now think about a scenario where switch 6 has to send a packet out, and the packet leaves all the ports which belong to that VLAN. So packet comes onto the switch 4. What now happens? Switch 4 repeats the same. It sends the packets out all the ports which belong to that VLAN and also the trunk ports which carry that VLAN. Packet also goes to switch 5. Now when switch 5 receives this packet, he examines the packet and sees that this packet has been received on the VPC peer link. So what it is going to do? It is going to tag this packet, or in other words, color the packet, mark the packet, and finally this packet will never be sent back to switch 6. So we won't have any kind of STP loop.
So what are the peer links and VPC member ports?
Okay, I think it's good time we explain the VPC terminology, because the more we will go ahead in this presentation, this terminology will help you understand better how VPC work. Okay, so we have a complete VPC domain here. So let's talk about the VPC domain first. So VPC domain includes all the VPC peer devices, VPC peer link, VPC keep alive link, and the member ports which form the virtual port channel by connecting to the downstream switches. It also is associated with the configuration mode where the global VPC parameters are defined. Then we have the VPC peer. So VPC peer is basically the combination of the two switches which are connected by a special port channel called VPC peer link. And one of these device becomes the VPC primary peer, other becomes the VPC secondary peer. So we have separate slides where we will explain like how primary and secondary election takes place. Then we have the VPC peer link. This is basically a layer 2, traditional layer 2 trunk, usually the 802.1 or .1q trunk, which can potentially carry all the VLANs. So this is a port channel that connects the VPC peers and is mainly responsible to carry the control traffic. This link usually doesn't carry any kind of data traffic, but there are certain scenarios when it can also carry the data traffic as well. Then we have the CFS protocol. So over this VPC link, we run a protocol called CFS, or the Cisco Fabric Service Protocol, which is used for the state synchronization and configuration validation between the VPC peers. All kind of MAC address table synchronization happens between the VPC peer using the CFS protocol. Then we have the VPC, or the virtual port channel, which is nothing but a bundle of two links which are connecting to two different physical switches, and this virtual port channel makes the two switches acting as one logical switch. We have the VPC member ports, and these are basically the ports on the VPC peers on which the physical links which form the VPC are connected. We have something called orphan ports. Before I explain this, I think it's good to explain what are non-VPC VLANs and VPC VLANs. So the VLANs which are allowed over the virtual port channel, they are called the VPC VLANs, and there may be certain VLANs which may not be allowed onto the VPC. So the port that you see here is not a part of VPC, but it carries the VLANs which are flowing over the VPC. So this is known as the orphan ports. And last but not the least, and very important link, is the VPC peer keep alive link. This link is also known as VPC fault tolerance link or the VPC backup link. Does not carry any kind of data traffic or the synchronization traffic. It is only used for carrying the heartbeat messages or the keep alive messages. So the basic purpose of this link is to monitor the vitality of the two peer devices. Using this link and using the keep alive messages, the two peer ensure that the other peer keep alive link is alive. Usually it is carried over a management interface or a switch virtual interface.
Okay, that's great. So one question many of our users are asking in the community today is how traffic flows through the VPC, which path it selects, and how.
Yes, Satish, we do have slides covering the traffic flow. Let me walk you across the packet flow. Let us consider a host with MAC address A wants to communicate with host with MAC address C. MAC address A will send the traffic towards the FAX switch. Once the FAX switch receives the packets, it will run the hashing algorithm to select one out of two uplinks. In this case, it selects a link towards the Nexus 5K1. Once the Nexus 5K1 receives the packets, it will save the MAC address A into its own MAC address table, and it will flood out the packets on every port on the same VLAN. It will also send a packet on the peer link towards Nexus 5K2. This is essential for communicating with a single home device if we have any on the Nexus 5K2. Once Nexus 5K2 receives the packet, it will flood the packets on every port on the same VLAN except the VPC member port. In our case, we don't have any port other than the VPC member port, so Nexus 5K2 will not send packet on any of the ports. Nexus 7K1 and 2 will run the same forwarding logic. Now, let us see the reverse path for the same communication. In this case, MAC C wants to communicate with MAC A. Host with MAC C will send a traffic on the Nexus 7K2, which is the upstream switch. Once the Nexus 7K2 will receive the traffic, it will check its own MAC address table to find out where to forward the packet. So in our case, Nexus 7K2 will forward the packet towards the Nexus 5K2. Once Nexus 5K2 receives the packet, it will check its own MAC address table, and it will find out that MAC A is connected locally over the VPC port. It will send a packet over the VPC port. So this is all about the forward and reverse packet flow. Now let us see the configuration and parameter checks. In traditional port channels, before two member link can form a port channel, they must agree on certain parameters. Similarly, virtual port channels are subject to certain parameters and configuration check. During a compatibility check, one VPC peer sends a configuration information to other VPC peer to verify whether the member ports can form a port channel or not. Let us consider an example where two member ports joining a port channel are carrying the different set of VLANs. This is a type of misconfiguration, and depending on the severity of the misconfiguration, VPC convey warning message or can suspend the entire port channel. So first case was the misconfiguration type 1, and the second case is the misconfiguration type 2.
So what are this misconfiguration type 1 and type 2, or maybe inconsistencies?
Okay, let me explain this, Harish. So as Pradeep mentioned, there are certain parameters which both links should agree before they can form a virtual port channel. So depending upon what parameters are missed, we decide whether it's a type 1 inconsistency or it's a type 2 inconsistency. So in case of a type 1 inconsistency, what happens that VPC or the virtual port channel gets suspended. From the Nexus OS 5.02, we also have introduced some commands. One of them is the Graceful consistency check. By default, this Graceful consistency check is enabled. So what happens with this is, if this command is enabled, which I have mentioned is by default, if there is an inconsistency, type 1 inconsistency, the primary VPC peer will keep the VPC up, but the secondary peer will bring its port down. On the other hand, if the Graceful consistency check is disabled by using a command no Graceful consistency check, what will happen is that both primary as well as secondary VPC peer will bring their port channels down. Now there is other inconsistency check, which is type 2 inconsistency check. In this case, VPC works perfectly fine, VPC remains up and running. Only a syslog warning message is generated which says that there is an inconsistency, and it also explains that what kind of inconsistency is there, and we should make sure that we remove this inconsistency as soon as possible, otherwise we can have some traffic disruptions. Now let's take an example for both of these kinds of type 1 and type 2 inconsistency. So what you see here is a type 1 inconsistency, because we have a VPC peer operation, and as you can see there are two switches 50201 and 50202. We are showing you the configuration. So on the 50202 there is an additional command entered which is spanning tree guard root, but this command is not available on the other switch. So if we check the show VPC brief, we see that our port channel 201 or the VPC is down. Its consistency status is showing as failed, and it also explains that what is the consistency failure, and it tells you here the reason that the STP interface port guard or the loop guard is on one interface but not on the other interface. So in a nutshell, we have a VPC down here because of a type 1 inconsistency. Then we have a type 2 inconsistency here, where you see that on the 50201 switch, we have allowed some VLANs in the range of 100 to 105. But on the right hand side switch, the allowed VLANs only in the range of 100 and 104. So we have not allowed 105 VLAN onto the right hand side switch. So now if we see the show VPC brief about this VPC port channel 201, we see that the port channel is up. Consistency check is also showing to be as success. Reason is showing success, but the active VLANs, if you see here, they are only 100 to 104. So they have suspended the VLAN 105. If you check the log message, it clearly says that VLAN 105 on the interface port channel 201 is not being working, and the reason they have mentioned that VLAN is not configured on the link. So in case of type 2 inconsistency, what we have here is the VPC remains up, operation remains up fine, but the VLAN 105 doesn't work. So while we are talking about the VPC consistency check, I also want to talk about a command which was being introduced in again NextOS 502, which is configuration sync. So what this command does is it simplifies the VPC operation by synchronizing the configuration between the primary VPC pair and the secondary VPC pair. So this command is actually based on the concept of configuration profile, which applies configuration to both local as well as the config sync pair at the same time. So this configuration sync happens over the management interface through the CFS protocol that I talked earlier, the Cisco Fabric Service Protocol over IP. So when we are using this config sync command, we should never forget about the commit command, because it is necessary for this to take place. And this commit is usually a two-phase operation. So what happens is either the configuration will be applied to both the peers, or this configuration will be removed from both the peers. But suppose your configuration sync pair is not reachable. So in this case, the configuration will only be applied locally, and once the pair becomes reachable, we will have the configuration merged. Alright, so now let's take an example about the VPC configuration, how we configure VPC. So when we configure VPC, please make sure that order does matter here and the command should be entered in a valid order. So first of all, we define the VPC domains. VPC domain is basically a numeric number, and we should make sure that this number should not be used for the two domains in the same layer 2 network. Otherwise, we may have some traffic disruptions. Then you need to establish a peer keep alive connectivity, which is basically on which the keep alive messages or the heartbeat messages flows. Then you need to create a peer link. Finally, we have to reuse the port channels that we had created, and we form the VPC. And also, last but not the least, make sure that the configuration on the links remains consistent. Otherwise, the VPC will not come up, or there may be some kind of VLAN suspension on the VPC. Let's look at some of the examples. So consider we have these two switches connecting to a third downstream switches forming a VPC. Here is the example of one of the switches. So first of all, you define the feature VPC. Now feature VPC is very important to define, otherwise VPC will not work. After that, we define a VPC domain, and in our case it is VPC domain 10. Then we define the peer keep alive link using a destination keyword, and after that there is an IP address which is of the VPC peer device. Then we have two optional commands, system priority and role priority. For system priority, you need to ensure that if it is manually configured, it should be same on both the switches, else VPC will not come up. The basic use of system priority is when we use LACP, and because in case of LACP, you can actually bundle together about 16 links, 8 of which remains up as an active and 8 of remains the hot standby. So using the port priorities, the controlling switch can decide which 8 links remains up and which 8 link remains in the standby state. And if you can use the lower system priority there, LACP will allow you to make a switch as a controlling switch, who can control which link remains active and which remains standby. Then is role priority. So role priority is the one which decides which switch becomes a primary switch. The default value for this role priority is 32667. So if you do not configure role priority, you will have the MAC address, the lower MAC address, just like in STP, to determine which will become a active pair and other will become a secondary pair. Then you go to the port channel, and which is the port channel between the two VPC pairs. You make it as a VPC pair link. Finally, you come down to the switches, which forms the port channel, and in the end, you go to the interface port channel, assign it a VPC. And similar configuration is done on the other pair. So if you see here, the role priority is 500. On the other hand side, the role priority on the other device is 1000. So as I explained, because it has a lower role priority, it will become the VPC active pair. On the downstream switch, the configuration is pretty simple. You just need to assign it to the virtual port to the port channels, and it will become a part of virtual port channel. Now, I think it's good time we discuss about some troubleshooting command or the show command as well that will help you verify the operation of VPC. So we have one slide here. An important command is show VPC brief. It will show you all the VPCs available on this switch or in this device. So for this particular switch, if you see here, we have a VPC domain ID as 10 because we have defined it as 10. Then it shows a peer status, which says that the adjacency is formed and it is perfectly fine. Then we have the keep alive link status, which says that peer keep alive is fine because on the keep alive link, they are constantly receiving the keep alive packets. Then the VPC role, so it says my VPC local pair is the primary switch, and number of VPC configured. So in this particular switch, we have only one VPC configured. If we check the status of peer link, it says it is up, ID is 1, and it also shows what all VLANs are passing over it. Similarly, it shows the VPC status, which is the port channel 20 here, and shows up and success. That means there are no consistency failure here, and it shows that what are the VLANs following over here. Another important command is show VPC pair keep alive. So this command basically gives you an idea about how the keep alive messages are flowing over the VPC pair link. So as you can see here, it says that my pair is alive, how long it has been arrived, when was the last pair keep alive received, what is the IP address of my VPC pair, what is my keep alive timeout and the hold time timeout intervals. Some other commands which are useful while troubleshooting are as follows: the show VPC role, which basically helps you understand what is the role of the VPC pair. It also tells you the VPC MAC address, VPC pair MAC address, and the system priority and the role priority. Then you can also check the show VPC statistics pair keep alive, which will basically give you an idea about how the VPC keep alive messages are flowing, and the stats about that. And about the consistency that we talked about, we have show VPC consistency parameters. So this command basically comes with two keywords. One of them is global, and one of them, what we are seeing here, is using the interface port channel command. So this command basically shows you all the parameters which are matched when the VPC pair keep alive, VPC pair link or the VPC comes up.
So when the peer link fails, how traffic is impacted?
Satish, I'm glad that you asked that question. And as I said, that VPC provides high availability in the data center. So we must definitely look at certain scenarios that could happen where we maintain high availability. So let's take a closer look here. We have a few slides. Now let's think there's one problem where the peer link fails. I mean, that's the link which is being configured as a port channel between the two primary and the switches and the secondary switch. Now in a VPC topology, as Vinay mentioned, we configure role priorities. This is what defines what is a VPC primary and what is the VPC secondary. Now in this particular failure scenario, what VPC secondary does is it suspends all of its VPC member ports if it can still receive a keep alive message from the VPC primary. Because obviously it knows that the primary is up, so it does not need to worry about forwarding traffic. And all the servers or the hosts, they redistribute their traffic towards the VPC member ports that is connected to Nexus 7K1. Now, let's think what happens if the peer keep alive link fails. Well, I wouldn't worry too much about it, Satish, because this link is, or this failure is basically a hitless failure. There's no impact to data traffic, and even the control traffic, there's no impact. However, we must maintain, or I must emphasize that this peer keep alive link should be corrected as soon as possible, just to avoid a dual failure scenario. Well, now the third scenario that I wanted to discuss was, we all know, right? power outages are a major catastrophe these days for entire world. What if there's a power outage in the data center or one of the switches fails? Well, it's not a problem. The other switch will take over and will work as the primary, and all data traffic remains constant. Now, if there was a power outage and both the switches go down and only one switch is able to come back up, we don't need to worry about whether it is the primary switch or the secondary switch comes up, but we will have an impact on the data traffic. Why? Because once the VPC pair comes up, it goes through a VPC election process, whether it becomes the primary switch or the secondary switch, right? But in this case, it cannot go through that election process because there's no other VPC switch available. So this is a point of worry. But as Cisco is always there for our customers, we have created mechanisms, or I should call them features, which avoid these kind of scenarios. These are reload feature and the auto recovery feature. So what these two commands of these features does is they would ensure that we bypass the consistency check in certain scenarios, thereby allowing the VPC pair switch to come back up and giving the data traffic a push. So that's how we take care of it. Now, that's not on the slide, but there are two other very particular or peculiar scenarios. What if a standard question? What if one of the member link fails? Well, I would not worry too much about it. It's not a big deal because as in traditional port channels, if one link fails, the other takes the traffic. In our case also, that will happen. If one link fails, the other one will take the traffic. But we must, figure this out that we will have limited bandwidth available for our use. So we must correct that link as soon as possible. Now, I explained about the peer keep alive link failure, right? So now imagine if you don't correct the peer keep alive as soon as possible and you have a dual failure scenario. So what if the peer link also fails? Now, in this case, it is very much possible that this is a cabling issue and both the switches are healthy. So to ensure we give maximum available bandwidth and the data traffic does not falter anywhere, what Cisco has done is both the pair switches, right? So the VPC primary and the VPC secondary switch, they both would remain up. They both would keep their member ports up and forwarding data traffic. This particular scenario is called a split brain scenario. And since both are forwarding traffic, so you have all the available bandwidth for use and there is no downtime anywhere. The only thing that we need to understand is that since the peer link is down, you would not have any layer 2 information exchange between the two switches. And it's just that the multicast and unicast forwarding tables will not be in sync, but your data traffic will not be impacted at all.
Okay, so VPC definitely looks a lot improved over spanning tree protocol. So since you guys are in planning, designing networks, what are the recommendations that you would like to suggest to our users who are designing the VPC domain?
Yes, Satish, there are certain things that we recommend customer to keep in mind. There are certain design recommendations while creating the VPC domain. Let us see the recommendation for the VPC peer link. To recall, VPC peer link is standard .1Q trunk which potentially carries all VLAN traffic. It also carries regular control plane traffic such as STP BPDUs, HSRP hellos. It also carries critical CFS protocol traffic which is marked with COS 6. VPC is critical for the VPC operation. Therefore, steps must be taken to ensure this link operates in most reliable and resilient way. Now let us see the general recommendation for the VPC peer link. Number 1, the VPC peer link should be formed on at least 2 × 10 gig, that too on a different line card. This will enable link level and line card level hardware redundancy. Number 2, the VPC peer link port should be configured as a dedicated bandwidth mode. Number 3, the VPC peer link port should be configured as a STP network port. This will enable bridge assurance on these ports, assuming bridge assurance is running globally over the switch. Number 4, enable the UDLT on these ports. This will help to cater the unidirectional link failure in case of it is highly feasible in the optical scenario. Number 5, running a dedicated VLAN or SVI over this link to cater uplink failure, for example towards the core link. Now let us see the design recommendations for the VPC peer keep alive link. Just to recall, VPC peer keep alive link is used to provide the protection against the dual active scenario which can happen in the case of primary link being lost. VPC peer keep alive link is used to determine the status of the opposite peer. If the primary link is down, it determines whether it is down due to the actual link failure or the node failure. VPC peer keep alive link use the simple heartbeat messages that are sent out every 2 seconds, and it uses 3-second hold time out period in case of primary link being lost. Now let us see the design recommendation for the VPC peer keep alive link. Number 1. The preferred option is to have a dedicated link using a dedicated VRF, and 1 Gbps is sufficient. However, this option is not efficient in case we don't have the 1 gig line cards. This option will be quite expensive in case we just have 10 gig line cards, and it is not efficient to use 10 gig port solely for the VPC peer keep alive link. In that case, we can use the option number 2, which utilizes a management interface sharing the management traffic. The third option, which is the least preferable option, is using the routed over the layer 3 infrastructure. Certain topology should not be considered. For example, where VPC peer keep alive link is routed over the VPC peer link. As we know, VPC peer keep alive link provides a protection or provides a backup to the VPC peer link. In that case, it doesn't make sense to route the VPC peer keep alive link over the VPC peer link. Now let us see the recommendation for the member port. Member ports, we already know, should match the parameters in order to make VPC up. There are certain parameters, for example, port channel configuration, STP configuration, MTU configuration, and VLAN allowed on the trunk. Just to summarize, in today's session, we covered VPC overview, operation, troubleshooting, configuration, failover scenarios, and design recommendation to ensure the stability of the VPC operation. There are more information available on our blog. Please do visit same.
Excellent presentation with a lot of animation. I really like that. So thank you, Pradeep, thank you, Vivek, and thank you, Vinay, for sharing your expertise today. So hope this Tech Talk on Virtual Port channel was useful to you, and we look forward to your feedback. You can send in your feedback using the comment section of this blog or video. You may also ask questions and collaborate via various social media channels like Facebook and Twitter. You can also catch us on YouTube, Google+, and LinkedIn. Goodbye, and thank you for watching.